the next question, number 31. A buck converter feeding a variable resistive load is shown in the figure. The switching frequency of the switch S is 100 kHz and the duty ratio is 0.6. The output voltage V0 is 36 volts. Assume that all the components are ideal and the output voltage is ripple free. The value of R in ohms that will make the inductor current IL just continuous is dash. Okay, so let's begin by writing down what's given. We have two very important values here. The duty ratio is 0.6. D is 0.6. And the output voltage is 36. V0 is 36. Right, we also have the frequency of the switch as 100 kilohertz or 100 into 10 power 3 hertz. Okay, so this is what we have. Now, if the output voltage is ripple free and the value is given as 36 volts, let's write down what is the output current I0. Now the expression I0 can be written in terms of the duty cycle, the duty ratio, and the input voltage Vin. So I0 is dVin by R. So this is one expression. I0 is equal to dVin by R. Now, if we are to find out the value of R such that the inductor current is continuous, now in order for the inductor current to be continuous, we have an expression. This is another standard equation. Delta IL is equal to D into 1 minus dVin divided by 2FL. Here, delta L is the inductor ripple current. This is another very useful formula. So the inductor ripple current in terms of the duty ratio and input voltage is given by this equation. Now since the question tells us that the components are ideal and the inductor current is supposed to be continuous, then that means that the ripple current, the inductor ripple current should be equal to the output current. If you look at the diagram here, IL is supposed to be equal to the output current I0. Now we have our expressions. We have D into 1 minus D Vin divided by 2FL. So that's delta IL is equal to, now I0 is D into Vin by R. So if we solve this in terms of R, let's do that now. So D and D cancels out. We will have our expression for R as 2FL divided by 1 minus D, since Vn and Vn also cancel out. So this is now our equation to solve. Let's plug in the values. So that's 2 into F is 100 into 10 power 3. That's the frequency given to us. The value of L, now what's the value of L given? 5 millihenry from the diagram down there. 5 into 10 power minus 3 divided by 1 minus D. Now what's the value of D? 0.6. Okay, now when we solve this, we get the ratio R is equal to 1000 by 0.4, and that gives us 2500 ohms. So the answer here is 2500. You can solve it and check if the value is right. 2500 is the final answer. So this is the entire solution, and I hope it has helped.